Hello everyone. Let's take a look at our challenge. I have this small teapot here. And as you can see, when I try to pour water into it, or just hold it, it leaks. It's practically useless for serving tea in its current state. You can see the water has just poured out. What a mess. This little teapot is quite the challenge. But every challenge is an opportunity for innovation. To begin, I'm selecting an old battery from this collection. My goal is to extract the carbon rod from inside, which is a key component for our project. It's often overlooked, but highly conductive. Carefully, I use pliers to peel back the metal casing of the battery. This reveals the inner layers, and I'm looking for that carbon rod in the center. This rod will serve as a heat-generating element. Leave a comment and let me know which country you are watching from. It's great that we can connect and chat from all over the world. Now that I have the carbon rod, I'm cleaning it with a paper towel. A clean and pure carbon rod ensures optimal performance and efficiency for its new role. Next, I'm taking an old electrical plug. I'll need to dismantle it to get to the metal components inside. I'm loosening the screw to carefully separate the plastic housing. From the plug, I'm salvaging one of the metal pins. These pins are made of conductive and resilient metal. I'm heating this metal pin with a torch. This process helps to soften and temper the metal, making it more workable for the next step. Now, I'm placing the heated pin in a vise and carefully hammering it flat. This step is crucial for creating a broader surface that will be easier to attach and integrate into our design. Next, I have a wire brush. I'm marking a point on the metal part of the brush handle with a marker. I'm using pliers to strip the bristles from another wire brush. If you find this video interesting, don't forget to like, subscribe, and turn on the notification bell so you don't miss any interesting ideas coming soon. I'm marking a spot on the metal strip where I'll drill a hole. Now, I'm attaching the sharpened metal pin to the metal bar with a small screw. Making sure it's secure is key for both safety and effectiveness. Next, I'm going to refine the shape of the screw with a grinder. This isn't just about aesthetics. Shaping it correctly ensures it fits perfectly into the handle and provides the right leverage for its function. Now, I'm taking a red electrical wire. I'm carefully stripping a small section of insulation from one end. This exposed copper will be our electrical contact point, crucial for conductivity. To secure and insulate the connection, I'm bending the metal strip to hold the wire firmly in place. I'm taking a red handle of a wire brush. I'm drilling a hole through it to accommodate the wire. Using a utility knife, I'm carefully carving out the inside of the red plastic piece. This creates a cavity for the internal components, ensuring everything fits snugly and is protected. I'm threading the red wire through the custom plastic handle. The red handle provides an ergonomic grip, and the metal tip is ready for action. For the other end of the red wire, I'm stripping a small section to prepare it for connection. This end will eventually connect to a power source. I'm taking a metal washer and threading it onto the stripped red wire. I'm crimping the wire tightly around the washer. This provides a solid, flat contact point for our electrical connection. I'm loading the carbon rod into the drill and using a piece of sandpaper to meticulously sharpen the end of the rod. The sharp end is crucial for precisely concentrating heat at the weld point, allowing for clean and efficient spot welds. I remove the carbon rod from the drill. I'm inserting the prepared carbon rod into the end of the metal pin on our red handle tool. This is where the magic happens. The carbon rod will get super hot. For the negative white wire, I stripped off the insulation and attached alligator clips to the end of the wire to ensure secure electrical connection. I repeated the process for the other end of the white wire, attaching washers to the end of the wire. Here's the power source for our amazing tool, a Makita 18B battery. I'm removing it from the drill because we'll be using it directly to power our new creation. Now, for the electrical connections. I'm attaching washers to the terminals of the Makita battery. This ensures a stable power supply. And now for the moment of truth. Watch closely as I touch the carbon rod to this razor blade. See how it instantly glows red hot and melts through the metal? It's incredibly effective for precision work, showing just how much heat this simple setup generates. To highlight the difference, I'm cutting a razor blade with scissors. Now, let's return to our original problem, the leaky teapot. I'm adding a small piece of metal under the teapot's handle where it connects. Then, I use my heating tool to solder into place, sealing any potential leaks and reinforcing the structure. This turns a functional weakness into a strong point. I'm doing the same thing with the remaining broken part of the handle. I'm adding a small piece of metal and soldering it to create a complete seal. This ensures no liquid leaks from the original seams. The teapot is now watertight. The teapot is now fully repaired and reinforced, all thanks to our custom heating tool. It looks good as new, but with added strength and functionality. Let's put it to the ultimate test. I'm pouring water back into the teapot. No more spills, no more drips. It holds the water perfectly. And here it is, perfectly functional. The water pours out smoothly and cleanly into the cup without a single leak. From a leaky mess to a perfectly sealed, usable teapot, this DIY device proves that with a little creativity and a few simple components, you can achieve amazing things and give old items a new lease on life. Thank you for watching, and I'll see you in the next one.